Hello from Rocket Lab's Mission Control Centre. We're live with a view of Electron on the pad at Launch Complex 1 in Mahia, New Zealand, for our 30th Electron mission, a dedicated launch for Japanese Earth imaging customer Synspective. My name is Felicity Powell, and I'm so glad you could join us for this landmark mission today. T0 is currently set for 0838 local time, and as this will be an instantaneous launch window, we have just one chance to fly per day. However, if we do need to stand down for any reason, we have plenty of opportunities over the next 13 days as a backup. If Synspective sounds like a familiar name, it's because they're a return customer to Rocket Lab, with today's mission being Synspective's third mission on Electron. We first launched for Synspective at the end of 2020 with the Owl's Night Begins, our 17th mission, a dedicated Electron launch of Synspective's cutting-edge Earth observation satellite, StriX-α. And then earlier this year, we launched them again, this time part of a 3-launch series of Synspective's StriX satellites with the Owl's Night continues. The 24th Electron mission was also the first launch from Pad B at Launch Complex 1, which we'll be launching from again this morning. Operating 2 pads at Launch Complex 1 doubles our launch capacity and eliminates pad recycle time, since we can switch between pads, enabling back-to-back missions like our recent missions for the NRO. Today's mission is called The Owl Spreads Its Wings, and it's carrying StriX-1, Synspective's first commercial SAR satellite. The owl is a symbol of wisdom and luck in many cultures, including Japan. Owls also have binocular eyes, much like we do, which gives them excellent visual acuity to judge height and distances. They have extraordinary night vision and the ability to see small details from far away. Barn owls of the StriX genus can also use their asymmetric ears to hunt using sound. In a similar way, the synthetic aperture radar technology on Synspective satellites, known by the acronym SAR, uses the echo of radio waves to create 2- and 3-dimensional images with millimeter-level resolution of the Earth's surface. Because the technology does not rely on visual electromagnetic wavelengths, it can produce these high-resolution images regardless of cloud cover or daylight. This resilience makes the StriX satellites ideal for complex tasks such as disaster response in all conditions, monitoring flooding and inclement weather systems, urban development and planning, and construction and infrastructure monitoring. Let's learn more about Synspective. today's mission isn't the last time we'll see the Owl taking flight from Launch Complex 1, with another Synspective mission already booked for next year. Now we're coming up on the T-minus 12-minute poll when our operators will run through the go, no-go calls with the launch director. Let's listen in to Mission Control to wait for the call.
In all stations, proceeding with the go, no-go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC's go.
Econ.
Econ is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
LD sup.
LD sub is go.
Okay, that is the go, no-go sequence complete. We are T-minus 11 minutes and 16 seconds and counting.
That's confirmation from Mission Control. All systems are healthy and we're proceeding with the remainder of the count. T0 is still targeted for 0838 New Zealand local time. It's currently 8:27 local time and we are 10 minutes away from liftoff from Launch Complex 1. Now, Launch Complex 1 was the world's first and is still the only private orbital launch complex. Established in 2016, we have now launched 29 times from this location, soon to be 30 with today's mission. We also have our second orbital launch complex on Wallops Island in Virginia, which is slated to launch its first Electron flight in December this year. We're excited to be debuting Launch Complex 2 and can't wait to share more about our plans at Wallops, with our new neutron production facility and launch pad being established on the island as well. Here's our VP of Launch, Sean DeMello, with more on LC1.
Launch Complex 1 is like no other launch site in the world. A lot of the design from our original Pad A and made some small improvements to make our operation that much more efficient. We use the same integration facility, the same rocket runway, with our final infrastructure all placed in a concrete pad no more bigger than a tennis court. With 2 launch pads, we have doubled our capacity and reached ultimate launch flexibility. This means when a customer needs us, we've got a pad ready. From LC1, we've flown over 100 satellites to date, all supporting everything from climate science through to international logistics, maritime surveillance, to the moon and beyond.
S-band has switched to high powerful flight.
Stage LD mission.
LD stage.
Proceed with sequence 57, the stage terminal checks.
Proceeding with sequence 57.
GC LD mission.
LDGC.
Proceed with sequence 58, launch pad ready.
Roger, proceeding with launch pad ready.
Stage 1 and Stage 2 high voltage batteries ready for flight.
All engine blips are nominal, all engines are ready. LD stage mission.
Stage LD.
Stage terminal checks are complete.
Copy, thank you.
As we prepare for launch, we're checking off a few more achievements for the year. 2022 has already been packed full of milestones. Our first launch from Pad B in February, our first helicopter catch recovery mission there and back again in April, and the success of the capstone mission to the moon for NASA, the first step in the Artemis program in July. Today's mission is also a landmark for our Electron program, including the 300th Rutherford engine we've flown to space and the 150th satellite delivered to orbit. Recently, we also conducted the first hot fire of one of our recovered Rutherford engines from the There and Back Again mission, another milestone in evolving Electron into the first reusable small orbital launch vehicle. Let's take a look. The movement of that engine is just part of our nominal test profile. With this milestone now complete, the next recovery mission is coming up later this year, and yes, we are bringing back the helicopter. So stay tuned for more details on that mission. We can't wait to share. Speaking of milestone achievements, earlier this year, Rocket Lab held a groundbreaking ceremony for our new Neutron production complex and launch pad, which, as mentioned before, will be in Wallops Island, Virginia. Neutron is Rocket Lab's next-generation launch vehicle in development, designed to lift 8 tons of payload and to provide a tailored launch solution for satellite megaconstellations. As a reusable rocket, Neutron is designed to land back on the launch pad after a mission, and from there it would be returned to the production complex for refurbishment and reflight. While today's mission will lift off from Launch Complex 1, we'll soon be seeing a different view as we prepare for our first mission from LC-2 in Virginia. That mission, for our friends at Hawkeye 360, is currently scheduled for launch in December, and we cannot wait to see Electron headed to space through Virginia skies. With that mission, we'll be launching Electron from a total of 3 pads, supporting a rapid launch cadence and offering our customers flexibility over their launch location and orbits. We are now moving towards the final stages of liftoff with T-minus 4 minutes remaining on the clock. At T-minus 2 minutes, Electron moves into terminal count, and the rocket's flight computers take over the countdown. Shortly after the 2-minute mark, we should hear the call that liquid oxygen loading is complete, which means that the vehicle is fully fueled and good to go. The next gate after that is the signal that the first and second stages are pressurized for launch. And finally, we await the 10-second countdown to liftoff with our launch director, Joseph Carpico. Let's listen in to Mission Control for these final steps ahead of liftoff.
It's LD to all stations on mission. From now on, there should be no red flags on your critical LCCs. VCON LD mission.
LD VCON.
Confirm all expected flight computer ASGOs are green.
Confirmed ASGOs are green.
And please lock the auto sequence and confirm.
Confirmed. Auto sequence is locked.
Okay, we're go for auto sequence start at T minus 2 minutes. LD is go for launch. LD Shadow, confirm go for launch.
LD Shadow is go for launch.
The vehicle is switched to internal power. All ground power disabled. Vehicle is fully on internal power. AFT is green and enabled for flight.
Lock load complete. Lock system in recirculation. All helium anti-geysering disabled.
Stage 1 and Stage 2 tank suppressed.
High flow engine purge enabled. Water deluge is activated.
T minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Stage 1 propulsion is
Our 30th Electron has taken to the skies, having successfully lifted off the pad at Launch Complex 1. You can see the distinctive shape of the Mahia Peninsula below as the vehicle is on its way to space, carrying our 300th Rutherford engine and 150th satellite. The next critical stage in Electron's flight is Max Q, maximum aerodynamic pressure. This is when the vehicle's velocity and local air density are at their maximum and the vehicle experiences the most mechanical stress. We'll hear that call from Mission Control when Electron clears that stage of flight.
Cleared Max Q.
Electron has successfully passed through Max Q and at an altitude of just over 15 kilometers is well on its way to pass the Kármán line and enter orbit. The 9 sea-level Rutherford engines on the first stage are operating nominally, and we are approaching the next series of events in the mission. The first step after Max Q is MECO, or main engine cutoff, when those first 9 engines throttle down before shutting off completely. This slows the vehicle marginally before the first stage separates from the vehicle. Once this is complete, the second stage space-optimized Rutherford engine ignites to take the payload and kick stage the rest of the way into orbit. These 3 events happen in quick succession, so keep an eye out and listen in for the call from Mission Control.
for MECO in roughly 30 seconds.
OS at Chettams.
15 seconds to MECO.
Eco confirmed.
Stage separation successful.
Stage 2 mission confirmed.
Done, done, and done. With that, we've confirmed MECO, stage separation, and ignition of the space-optimized Rutherford engine on the second stage. At this point, as Electron has cleared most of Earth's atmosphere, it can also jettison the payload fairing, as it is no longer needed to protect the payload. You can see it there on your screens. Electron's fairing has now been ejected, with the two pieces falling away. Electron's second stage is continuing nominally on its way to orbit, carrying its Synspective payload, which is now exposed in preparation of deployment. The vehicle is currently reaching speeds of more than 8,000 kilometers per hour and at an altitude of 131 kilometers. The vehicle is continuing nominally on its flight to low Earth orbit, currently traveling at a speed of over 9,000 kilometers per hour and an altitude of 140 kilometers. As Electron lifted off the pad, you would have seen big clouds of what looks like smoke billowing out from under the vehicle. That's actually steam, produced as the exhaust of the engines makes contact with the water deluge. We use water to absorb the immense sound energy produced by those 9 Rutherford engines at liftoff. We're now almost 5 minutes into the mission for the Owl Spreads Its Wings, our Electron flight for Synspective. The vehicle with payload is traveling at a speed of over 11,000 kilometers per hour, currently at an altitude of 176 kilometers, well on its way to low Earth orbit. The low Earth orbit zone, often noted as LEO, is classified by having an apogee of less than 2,000 kilometers, or approximately 1,200 miles.
Stage 2 propulsion holding nominal.
Next up is a step we refer to as the battery hot swap. The Rutherford is a unique engine in that it is powered by electric pumps, which draw energy from batteries. Once those batteries are depleted, they're just dead weight, so we shed them to swap out for a fresh one. If you watch carefully, you'll see that shiny silver battery separate from Electron soon.
HVB battery discharge holding nominal, approaching hot swap in roughly 30 seconds.
Throttling down.
You might have seen it there. Battery hot swap has been successfully completed, and a new battery is powering the second stage onto orbit. Our 30th Electron vehicle is in the air and on its way to space, continuing our mission to make space accessible for all. We're also on a mission to make the space industry accessible to all, with more opportunities and pathways into careers with Rocket Lab than ever before. It's never too late to reconsider an old dream or a new aspiration and reach for the stars with us. Check out the careers page on our website, or if you're not quite ready for recruitment, our education programs will help get you there. Go to rocketlabusa.com to find out more.
HVB battery discharge holding nominal.
Electron is currently at an altitude of 206 kilometers, traveling at a speed of over 19,000 kilometers per hour on its way to space. While this particular mission is not a recovery mission, our recovery program is progressing at speed, with the first test of a recovered Rutherford engine just 2 weeks ago, and it was a roaring success. We're looking forward to the next 30-minute missions and beyond, perhaps even flying fully reusable hardware to improve sustainability and value for our customers. The next major milestone we're approaching is second engine cutoff, or SECO. Just like MECO, our space-optimized Rutherford engine on the second stage will throttle down ahead of separation from the kick stage, which takes the payload to exactly where it needs to go.
Guidance is in terminal, 27 seconds remaining.
SECO confirmed.
1 minute transfer orbit.
Stage 3 separation confirmed.
You may have heard the call there. The vacuum-optimized Rutherford engine has throttled down, and the kick stage has cleanly separated from the second stage. From here, the small but mighty Curie engine will take the payload to its exact destination in space. For the next 50 minutes or so, the kick stage will enter a coast phase until it reaches the apogee of its elliptical orbit, the furthest distance away from Earth. From here, the Curie engine kicks in to adjust its perigee to a circular orbit at this point. Once it reaches the orbit our customer has requested, we'll deploy Synspective's StriX-1 satellite to its new home in space. We won't have a live video feed from the kick stage on this mission, but we will stay with you on this webcast to bring you a simulated view of payload deployment. We'll take a bit of a break on the webcast now, but we'll be back with you closer to payload deployment to listen in on those final moments from mission control. This last step in the mission is expected to take place at T plus 53 minutes, and we'll see you back here then. Welcome back to the webcast of Rocket Lab's 30th Electron mission, The Owl Spreads Its Wings. If you're just joining us, today's launch included a successful on-time liftoff at 0838 New Zealand local time, or 2038 UTC. The Curie engine on the kick stage is completing the burn to circularize its orbit, with Synspective's StriX-1 satellite on board. Once this maneuver is complete, we can deploy the satellite to its new